Our last step today for moving down to the machine level of abstraction is to stop relying on Plait's ability to allocate records and pattern match on it. So here, where we used to have a creation of a multi-second K record with 3 fields, we're instead going to take control ourselves and allocate some bit of memory that has room for 3 fields. And this 3 here is not because of the 3 fields. This 3 is going to turn out to be the number that means multi-second. That is, we have different kinds of records that we need to represent as distinct, and so we'll just pick a different number for each of them. Specifically, we'll use the number 1 to mean a done K record, 2 to mean a plus second K record, and so on. We will also need numbers for our different expds, because we're going to replace the type case there with the dispatch on numbers as well. And finally, there are values that we make and recognize at runtime, so we'll need to give those a tag as well. In other words, for every different variant that we had in our interpreter that was used by interp, continue, or helper functions, we need to pick a distinct number for it instead. And we're going to put that number at the beginning of each object as we allocate it in memory. That means that our continue, say, the continue function, which used to do a type case on continue records, will now do a plain old case on a number. So kreg is going to be the address of some continuation record in memory. And we'll look at the 0th offset of that bit of memory to get a number, which will tell us what kind of continuation we have. So 3 will mean that we have a multi-second K continuation. And where we used to rely on type cases pattern matching to pull out these field values from the record, instead we'll do the work ourselves. We have this kreg value. It's a number that represents the address of the continuation record in memory. So we will offset that by 1 and look in memory to get the first field, offset it by 2 and look in memory to get the second field, and so on. In other words, memory is just going to be a big array of numbers. Arrays are called vectors in Plait. So we will make initially a vector of, say, 1.5k slots, fill them all with 0 initially, and then we've got this extra register that's going to be our current allocation pointer into that memory. So it starts off pointing at the beginning of the memory, and as we increment the number, it's pointing later into this memory vector. The malloc3 function, which takes a tag and 3 field values, will work by installing that tag at the current allocation pointer and installing the A, B, and C fields beyond, offset appropriately from that allocation pointer. Then we increment the allocation pointer by 4. That's because we have 3 fields plus a tag. And then this is just a way of returning the old allocation pointer without having to deal with extra registers or temporary variables. We just subtract 4 back off. So when we malloc 3, then we'll use up 4 spaces in memory. The next allocation will use the next 4, and so on. And that way we've made all allocation explicit, and everything now is a number. There's no records or symbols or other things involved.